Great. Hi guys, we're moving on to some very important work, and I am sure you guys will understand it. And this is called factorising, and this is algebraic work. And just a reminder that we're working in book 1. So for factorising, we need to know what are factors. So remember, factors are basically when you break a product up into its two numbers that you can multiply together to give you that value. So just as an example, we factorized earlier this year. Let's say we want to factorize 24, then we can factorize it to be either 6 times 4, so it's 6 and 4 that gives you that number, or you could say 12 times 2, or the factors that make up 24 could be 8 and 3, and or the last pair of factors that could give you 24, of course, is 1 times 24. So now the method, the algebraic aspect of this would be you're looking for something that multiplies to give you the values or the product. And it doesn't work like that for algebra necessarily, but you can easily see how we've done it for normal rational numbers so far this year, and it's also going to apply to the coefficients of your algebraic expressions, of course. But when it comes to the stuff like I have A, B, then the factors of this expression would be A times B, or if I have C, A, then the factors multiplied in this is A and C. And now we can see in both of these expressions or terms we have a common factor of A. So common factor for this is A. Okay? And let's say we have 5, so let's just circle this so we know how to find the common factor with the variable. So let's say we have 5 AB and 10 AB. AC. Then we already know A is a common factor between AB and AC or CA. Remember, that is commutative. It doesn't matter the order in which you write a multiplication calculation. But between 5 and 10, the factors that are common are not as obvious. And usually we would write out all the factors, or we just know them sometimes. So we can write out the factors of 5 is 1 and 5 because it's a prime number. And then the factors of 10 is 1, 2, 5 and 10, and then we notice that 5 is the highest common factor. Okay, so therefore I know I have a 5 in common as a factor because 10 is 5 times 2, A times B, A times C. Okay, and then we also see from this that 5 is our common factor. So the total common factor here in this expression is 5. And then we've already gotten from here that it is A as well. Okay, so 5A. And if you look at it anyway, A is the other number they have in common. Right, so an example that's broken up a little bit for you guys to introduce it. And this is the first kind of factorizing that we're going to do, which is the common factor. We're going to do it over 2 days. So the common factor would mean it's a factor or number or variable that is the same in both or more than whichever amount of terms you have in an expression. Okay, so if I have we've already discussed what it means if I have the factors of 6 and 2, and I want to find the common factor, then the common factor of 6 and 2 are 3. Okay. It would be 2. And then in the same manner we can factorize this, and it becomes that 15 can be broken up into 3 times 5, and x squared can become x times x, and then y. And this helps if you can break it up into parts like this, and as I've done in the video in the previous slide, because then you can underline those factors that it has in common, and you can actually see how many x's it's got in common, for example. So if you struggle with this section, try and compartmentalize it. Okay, so as you know, common means the same. Now the method, you bracket your expression. You're going to see me do it in the examples just now. And then when you so you need to write these notes down. Sorry for interrupting myself. You need to write these notes down into your book so that you know the steps and can have easy access to it. You have to look for the highest common factor. In other words, a factor that is the same in each of your terms. And then you basically, when you are taking out the highest common factor, you are dividing each of the terms by the highest common factor in the expression. And then you keep the highest common factor outside the bracket to show that it's a common factor, and you simplify each term inside the bracket. I just want to put it into perspective for you guys. So if I had 5x, which was multiplied by 2x plus 1, then we would of course distribute, and 5x times 2x gives you 10x squared, and then 5x times 1 gives you positive 5x. Okay, so that common factor, that factor of 5x, is contained in each of the terms in my product over here, 10x squared, and in 5x itself. Okay, what we're doing by taking out a common factor is by reversing this process that we have learned to distribute into the brackets. Okay, so that's basically what it is when we are factorizing using a common factor. And then just a few notes to remember. When you divide by the same base, we subtract the exponents, and then if you get the result of subtracting such exponents as 0, then remember, anything to the power of 0 is 1. So now we've got AB plus AC. The first step is to bracket your terms, the expression as such, and then we take out a common factor, which is easy to see when it's variables. Okay, A and A is common to both, or is the same in each of our terms. So that goes in front of the bracket. A is my common factor, but then you're basically dividing inside the bracket by A. So dividing by A in the first term, basically this happens. A divides by A leaves you with 1. A divides by A leaves you with 1 for the second term, and then therefore A times B plus C would be the factorized form of AB plus AC. And if you multiply in here again, A times B is AB, and A times C is positive AC. You will get back that expression that you originally had to factorize when you distribute again. So you can use it as a kind of a test to check your answer. Okay, so that's what I mentioned over here. And then number 2, we have 3ABC plus 3AB. And once again, it's relatively easy to see that the factors in common is 3 in each. There's an A in each, and there's a B in each term. So we go ahead and we bracket the whole expression, so we know the brackets are there. The brackets are always there anyway, we just don't always write it. And then we take out the common factor, which we said is 3ab, and then inside the brackets we divide each of our terms by the common factor that's outside the bracket, 3ab. Okay, and then we divide in the brackets itself, get the answers, and remember, so 3 divides by 3 is 1, a divides by a is 1, b divides by b is 1, and all that remains in that first term in the brackets is c. Plus the second term, we've got 3 divides by 3, a divides by a, b divides by b, and for each one of those the answer is 1. So 1 times 1 times 1 means for the second term in the brackets, the result is 1. And if you distribute again, you will get 3abc plus 3ab. Okay, 3ab times c is 3abc, plus 3ab times 1 is 3ab. So it proves to be true again. Then for number 3, as you see here, if you go and do a bit of investigation, the highest common factor of these three numbers, -3, -12, and 9, is -3. Remember, if your first term is negative, you always take out a negative as a common factor. And then the lowest degree, like mentioned in your steps, will be the degree of x that we are going to take as a common factor, because the other terms would not have enough to regard it as a common factor, enough of the x's being multiplied. Okay, so in this regard, -3 for the coefficients, and then for the variable x, the highest exponent is 1, so our highest common factor is -3x. So we say bracket the whole expression, and then we take out the common factor and divide each term by that common factor. Sorry, I'm writing over the words there. So if I divide, then it will give me the result of the factorising. So -3x as the common factor. And then if I divide in each term, and you don't have to actually write it like this every time, you'll get better at it. So you don't have to write the dividing inside the brackets. You can literally just do it by yourself. But do that until you feel more comfortable doing the factorising. So in the first term in the brackets, a negative divided by a negative is a positive, and then 3 divided by 3 is 1. And then, so I'm just not going to write anything in the place of that, we're dividing x to the power of 3 by x, meaning 3 minus 1 is 2 for the exponent of x. So it's x to the power of 2, or basically 1 x to the power of 2. That remains for that first term in the brackets. Then a negative divided by a negative is a positive. So remember that negative divides by that negative. And then 12 divided by 3 is 4x to the power of 2 divided by x. 2 minus 1 for the exponents gives you x to the power of 1. And then in the last term in the brackets, a positive divided by a negative is a negative. 9 divided by 3 is 3. And x divided by x is 1, and we won't write anything in the place of that since it's multiplied by -3, leaving it as -3. So this is the fully factorized form of that expression. And have a look at Spot On Mathematics, grade 9, activity 5.3a, only question 3 for the 24th of June, and then for the 25th of June, this worksheet A over here, common factor.